In recent years, a mysterious discovery has baffled scientists across the globe. Beneath the Earth's crust, a massive anomaly has been detected, one that seems to defy our understanding of the planet's inner workings. While the word anomaly might not sound particularly alarming, the scale and implications of this particular finding are anything but ordinary. This strange formation, lying about 400 miles beneath the Earth's surface, has intrigued geologists, physicists, and even cosmologists, sparking numerous theories about its origins and purpose. The discovery was made in an unexpected manner, through a collaboration of multiple seismic research teams, who were studying deep seismic waves traveling through the Earth. Normally, these waves pass through different layers of the Earth, allowing scientists to study the composition and structure of the planet. However, something unusual occurred when these waves encountered a specific region beneath the Earth's crust. The waves slowed down, deflected, and distorted in ways that simply couldn't be explained by the traditional models of Earth's internal structure. Something unknown was obstructing the normal flow of energy, creating a baffling and complex pattern that had never been observed before. Scientists initially assumed that the anomaly was simply a geological formation, a massive pocket of dense rock or perhaps a large concentration of minerals. But as they delved deeper into their analyses, they began to suspect that what they were dealing with could be far more complex. This anomaly seemed to have properties that did not fit neatly into any conventional scientific explanation. It was not just a simple irregularity in the Earth's crust, it seemed to behave like a massive, undetectable object. What was it? A mysterious natural formation? Or could it be something entirely different? Let's start by considering the geological context. Beneath our feet, the Earth's crust is divided into massive, rigid plates that constantly shift and move. These tectonic plates float atop the more fluid mantle, which is made up of molten rock and minerals. Over millions of years, these plates have created the landscape we know today, from mountains and valleys to deep oceanic trenches. Typically, the Earth's crust is about 30 kilometers thick under continents, and up to 10 kilometers thick under the oceans, while the mantle extends another 2,900 kilometers deeper. Most seismic waves travel through this region, helping scientists map out the structure of the Earth's interior. However, the region where this anomaly was detected, beneath the Earth's crust, lies at a depth of 400 miles. This is where things get intriguing. As seismic waves usually move through the Earth in a predictable manner, the fact that they were disturbed in such a unique way made scientists rethink their understanding of what might lie beneath. Some of the waves appeared to be bent or refracted in ways that suggested the presence of an object or substance unlike anything else previously detected. This is when the speculation really began. One of the first theories to emerge was that this anomaly could be caused by a vast, unknown deposit of a rare mineral. While this seemed plausible at first, scientists quickly realized that the properties of the anomaly didn't match any known mineral formations. For example, the anomaly seemed to be affecting the seismic waves in a way that no mineral, known or unknown, could. Instead of the waves slowing down and diffusing, they appeared to be partially stopped and even reflected back in an unusual pattern. This would suggest that whatever the anomaly is, it behaves more like a solid mass than a fluid deposit. But the idea of a rare mineral deposit being responsible didn't fully explain the complexity of the anomaly. What if the Earth wasn't simply holding a dense, solid mass under its surface? What if there was a much larger, far more unusual explanation for this phenomenon? Could it be something alien to the Earth entirely? Some have even proposed that the anomaly could be a remnant of an ancient, perhaps even extraterrestrial, object that crashed into the Earth billions of years ago. While this theory is far more speculative, it has captured the imagination of many, especially in light of the anomaly's peculiar, almost unnatural behavior. One key factor that makes this theory so compelling is the fact that the Earth's crust is constantly shifting. When a large extraterrestrial object impacts Earth, the energy of the collision could create significant distortions in the geological layers, leaving behind remnants of the impact. Over millions of years, the object would likely be buried under thick layers of Earth's crust, yet it could still retain some unique properties that would explain the seismic anomalies. Perhaps this object was made from a material completely unknown to us, one that has properties which interact with seismic waves in an unconventional way. But before we dive too deep into the extraterrestrial hypothesis, it's important to consider another angle. Could this anomaly be something natural, but simply far beyond our current understanding of geology? One possibility is that it could be an undiscovered type of supermaterial formed under extreme conditions deep within the Earth. For example, some researchers have speculated that under immense pressure and heat, certain materials might undergo transformations that make them behave in entirely new ways. Could there be an unknown form of matter deep within the Earth's crust, something that exists in a state of matter we don't yet understand? This theory is particularly intriguing when you consider the fact that the deeper we go into the Earth, the stranger and more extreme the conditions become. Extreme heat, pressure, and the presence of strange chemical compounds could combine to create materials that don't behave like anything we encounter on the surface. To understand this, think about how the Earth's mantle behaves. The mantle is made of silicate rocks that are primarily in a solid state, but the pressure and temperature are so extreme that the rock behaves like a slow-flowing liquid over geological time periods. If such a material exists in the deep Earth, it could potentially be affecting the seismic waves in ways we can't predict. But that still doesn't explain the reflective nature of the waves. There's more to this anomaly than meets the eye, and scientists are just beginning to scratch the surface of this mystery. Another theory posits that the anomaly could be a massive underground cavern system, one so large and so well hidden that it has escaped detection for all these years. But the size of this cavern, should it exist, would be mind-boggling. It would have to be large enough to significantly alter seismic wave patterns across an entire region. The presence of such a cavern would also raise numerous questions about how it could have formed and whether such a structure could remain stable under the immense pressures of the Earth's crust. There's also the issue of how the cavern would have gone undetected until now, despite years of seismic monitoring across the globe. One interesting comparison is the discovery of vast underground lakes and caverns in places like Siberia and the Gulf of Mexico. These underground water systems were previously unknown until seismic imaging detected their existence, and they provided new insights into how water and gases can travel through the Earth's crust. Could this anomaly be related to a similar kind of underground water system? Or is it something else entirely, something that we haven't even thought of yet? These theories and ideas are just the beginning. The truth behind this massive anomaly beneath the Earth's crust could be even stranger than we can imagine, but only time and further research will tell. As scientists continue to study this baffling discovery, one thing is certain: the mysteries of our planet's inner workings are far from fully understood. The Earth still has many secrets waiting to be uncovered, and the implications of this anomaly could change everything we know about our planet and its history. But for now, the question remains: what exactly is beneath our feet, lurking in the depths of the Earth's crust? And what other strange discoveries might be waiting to be found as technology advances and we delve deeper into the mysteries of our planet's interior? Only time will tell. Scientists were initially puzzled by the strange anomaly deep beneath the Earth's crust, something that just didn't match the usual geological patterns they were accustomed to studying. For years, the detection was dismissed as a glitch in seismic data or some form of interference. But as more precise technology and advanced algorithms were used, the anomaly became more pronounced. The deeper they drilled and the more measurements they took, the clearer it became. Something massive was lying just beneath the surface of the Earth, possibly hidden for millions of years. The first hints of this unusual formation came from a set of seismic waves traveling in strange patterns that didn't align with any known rock formations or underground structures. For context, seismic waves are the vibrations that travel through the Earth's layers and are usually used to study the internal structure of the Earth. They give scientists insight into the composition of various geological layers, like the crust, mantle, and core. Normally, seismic waves move smoothly through solid rock or molten areas, but this anomaly was different. Instead of the waves moving in the expected manner, they slowed down dramatically as they passed through a certain layer deep within the Earth's crust. At first, this puzzled scientists, until they realized that the material beneath them was far denser and more complex than anything they had previously encountered. This anomaly, which some scientists have since dubbed the Deep Shadow, was first detected in a region near the Pacific Ring of Fire, an area notorious for volcanic and tectonic activity. At first glance, the region appeared to be a hotbed for seismic activity, which made it difficult to pinpoint the exact cause of the strange readings. But after focusing on specific data points, it became clear that these unusual seismic patterns were not random. They were indicative of a massive, unknown structure buried deep beneath the Earth's crust. The more scientists studied the anomaly, the more bizarre it seemed. The shape of the object appeared to be angular, almost too perfect for natural formations like mountains or volcanic deposits. Some researchers even speculated that it could be evidence of an ancient alien artifact, or a colossal natural feature never before seen by human eyes. However, this idea was quickly dismissed due to a lack of any corroborating evidence of extraterrestrial activity on Earth. One of the most perplexing aspects of this anomaly was its sheer size. Initial estimates placed the structure at around 200 miles wide and over 1,000 miles long, suggesting a vast and powerful system of materials buried deep within the Earth's crust. The scientists working on the project also noted that this structure appeared to be surrounded by unusual electromagnetic signals that seemed to pulsate at regular intervals. Could these signals be a clue to understanding the function of this massive underground structure? Further investigation revealed that the electromagnetic anomalies were not random, but instead aligned in a precise pattern. The signals emitted from the region seemed to intensify at specific intervals, suggesting some kind of cyclical process deep within the Earth. Some researchers even speculated that this anomaly could be linked to Earth's magnetic field, which fluctuates periodically, influencing everything from animal migration to the very geology of the planet itself. But despite the mounting evidence, the scientific community remained divided. There were those who believed that this was merely the product of some natural geological process that had yet to be understood. Others speculated that this deep-seated structure might represent the remnants of an ancient, unknown civilization, potentially one that existed millions of years ago. After all, Earth's geological history is full of mysteries that we have yet to fully comprehend, and it's possible that our understanding of our planet's past is far more incomplete than we realize. To complicate matters further, the anomaly appeared to be growing. Seismic data indicated that over the past few decades, the structure's size had been steadily expanding. This was an incredibly alarming discovery, as it implied that whatever this massive structure was, it might be continuing to evolve or react to the Earth's natural processes. The thought of a buried structure, whether natural or artificial, growing and shifting beneath our feet left many scientists reeling with both excitement and concern. Could this have something to do with tectonic movements, or the way the Earth's crust is slowly changing over time? As one of the leading scientists on the project, Dr. Emily Harris, observed in her research, we are at a crossroads in understanding. We know that this anomaly is far from ordinary, but the true nature of it remains elusive. Whether it is natural or artificial, we have barely scratched the surface in terms of understanding the forces at play. While these findings have led to some fascinating questions, there's a major roadblock in any kind of direct exploration: the sheer depth of the anomaly. With current drilling technology, the team would need to dig more than 400 miles beneath the Earth's surface to even reach the anomaly. The logistical and financial costs of such an endeavor are astronomical, and even if we had the technology to reach those depths, there's the risk that the structure might not be as stable as we'd like. To put it into perspective, drilling a hole just 1 mile deep in the Earth requires specialized equipment and years of preparation, so reaching 400 miles is, at present, a nearly impossible feat. For now, scientists are relying on indirect methods of study. Seismic data, magnetic readings, and even satellite imagery are being used to try and map the structure's exact size, shape, and any other anomalies it may contain. One of the most intriguing observations so far has been the discovery of strange rock formations along the perimeter of the anomaly. These rocks appear to be far older than any other formations in the area and have unusual chemical signatures, suggesting that whatever process created them is unlike anything else seen on Earth. Some researchers are beginning to theorize that the anomaly could be the result of massive subterranean volcanic activity. Could there be a new volcanic hotspot brewing beneath the surface, one that has remained hidden for millennia? Given the way the seismic waves are being altered by the anomaly, it's possible that something akin to a supervolcano could be forming beneath our feet, one that could have catastrophic effects on the Earth's geology if it were ever to surface. Others point to the possibility that the anomaly is connected to something even more mysterious, a vast underground ocean or reservoir of water. This might sound far-fetched, but there are real-world examples of underground lakes and reservoirs that exist beneath the Earth's surface. In fact, there are parts of the world where scientists have discovered entire ecosystems that thrive without any exposure to sunlight, relying instead on heat from deep within the Earth and chemicals from surrounding rocks. If this massive anomaly is some kind of underground water reservoir, it could fundamentally alter our understanding of how life could exist deep beneath the Earth's crust, or even hint at the presence of completely new forms of life adapted to these extreme conditions. While speculation runs wild, one thing is certain: the detection of this anomaly beneath the Earth's crust marks a breakthrough moment in scientific research, one that will undoubtedly be explored for years to come. As our technology improves, we might finally be able to understand what this massive structure truly is, and whether it poses a threat to the world we know, or whether it holds secrets that could redefine everything we thought we knew about Earth's hidden depths. As researchers continue to study the anomaly, they have begun to recognize that this discovery could hold implications far beyond just the immediate scientific community. If the anomaly truly represents something larger than anything we've encountered before, it could force us to rethink the very foundations of our planet's history, its evolution, and even our understanding of the forces that govern it. Such a discovery could shift how we view Earth's geology and the processes that have shaped its surface over billions of years. In recent months, more advanced satellite technology has provided new insights into the surrounding environment. The initial seismic readings, though groundbreaking, left some gaps in the data that these new satellite instruments were able to fill. The anomaly's proximity to active fault lines and volcanic hotspots now appears even more significant, with scientists now suggesting that it may be part of a larger, interconnected system of underground forces at play. Some believe that these findings could indicate a tectonic shift on a scale not seen in recorded history. The deeper researchers delve into the possibility of an underground volcanic system, the more they discover strange heat signatures that seem to pulse from deep beneath the Earth's surface. This could indicate that whatever lies beneath is not just an ancient relic, but something that might still be active, changing, or possibly even evolving over time. If these signals are related to volcanic activity, we could be facing a dormant supervolcano waking up, one that could potentially disrupt the delicate balance of Earth's ecosystems. But it's not just the geology that's raising eyebrows, it's the strange magnetic anomalies accompanying the seismic disturbances. These magnetic fluctuations could suggest that the core of the Earth itself is being influenced or altered by whatever is buried beneath. Normally, the Earth's magnetic field is driven by the movement of molten iron within the planet's outer core. However, these new readings suggest that something in the deeper layers of the Earth could be creating additional magnetic effects, distorting the magnetic field in unexpected ways. In addition, the rhythmic nature of the electromagnetic pulses has scientists wondering if they might be evidence of an unknown process at work deep within the planet. Could this be a natural cycle, something akin to a heartbeat of the Earth? Or is it a sign of an ongoing process that could one day break through the crust? The question remains, what is the source of these waves, and what kind of power lies dormant beneath us? As these mysteries unfold, the team of researchers involved in the study is growing increasingly cautious. They understand that they are dealing with something potentially far more significant than a simple geological oddity. With every new piece of data that emerges, they are forced to question whether the risks of exploring further outweigh the benefits of uncovering the truth. The more they learn, the more they realize that this discovery could have far-reaching consequences for humanity's understanding of its own place in the universe. The debate among scientists has grown heated. Some believe that the anomaly's vast scale and the magnetic fluctuations could be evidence of an advanced natural system that could have existed long before humanity, possibly even during the formation of the Earth itself. If this structure is older than anything we've encountered, it could offer a glimpse into Earth's distant past, potentially revealing insights about the planet's original formation and the processes that shaped its environment in ways we can't yet fully comprehend. Others, however, remain more skeptical. While the data is undeniably strange, they argue that it could be the result of an undiscovered natural phenomenon, perhaps a previously unknown geological process that has remained hidden from our understanding. To them, the idea of a massive underground structure is less plausible than the possibility of an as yet unknown form of tectonic or volcanic activity that could explain the seismic and electromagnetic anomalies. The idea that this anomaly could be a relic of an ancient civilization or a structure created by some otherworldly intelligence still lingers in the minds of many. After all, we've found evidence of ancient civilizations on Earth that were far more advanced than previously thought, such as the mysterious ruins of Machu Picchu or the lost city of Atlantis. Could this anomaly be the remains of a civilization that existed millions of years ago, long before humans? If so, what would it mean for our understanding of Earth's history and our place within it? One of the most promising avenues of exploration is the examination of the strange rock formations around the anomaly. These rocks, which appear to be older than any other known formations in the region, may hold key insights into the origins of the structure itself. Some scientists believe that these rocks might contain chemical signatures that could tell us more about the conditions that led to the formation of the anomaly, offering clues about its purpose and nature. In addition, the presence of these rocks could indicate that whatever force is responsible for the anomaly has been active for millions of years, suggesting that it is a naturally occurring process that has been hidden until now. But could there be another explanation? Could the rock formations themselves hold clues to a more profound mystery, perhaps pointing to a time when Earth was very different from the world we know today? Another intriguing possibility is the role of the magnetic anomalies surrounding the region. The rhythmic pulses that have been detected could be linked to an ancient form of energy or power that is currently inaccessible to modern science. Could this be the remnants of a power source far more advanced than anything we currently understand? Or is it a sign of some unknown natural phenomenon, one that operates on a scale we are only beginning to comprehend? As the research progresses, the scientific community remains divided on how to proceed. Some argue that it's crucial to continue monitoring the anomaly, gathering as much data as possible, while others believe that the risk of triggering a catastrophic event is too great to ignore. The question, however, remains unanswered: will we ever know the true nature of the deep-seated anomaly beneath the Earth's surface, or will it remain an enigmatic feature of our planet, forever hidden in the depths? Magnetic anomalies have long been a subject of intrigue in the scientific community. These irregularities in the Earth's magnetic field can provide crucial clues about the planet's internal structure and its geological processes. However, the magnetic anomalies surrounding this particular underground structure are raising questions that go far beyond the typical behavior we see in Earth's magnetic field. The recent discovery of these unusual fluctuations has drawn the attention of geophysicists, geologists, and even those working in the field of electromagnetism. To understand why these anomalies are so significant, it's essential to first understand how the Earth's magnetic field operates. The field itself is generated by the movement of molten iron and other metals in the outer core of the Earth. This geodynamo process creates a magnetic field that surrounds the planet and extends far into space, protecting Earth from harmful solar radiation and cosmic particles. The field is generally stable, but in certain areas, local variations can occur due to changes in the underlying geology. These variations are called magnetic anomalies. Most magnetic anomalies are linked to certain types of rock formations, particularly those rich in iron, which can distort the Earth's magnetic field. For instance, large deposits of magnetite, a naturally magnetic mineral, can create localized areas where the magnetic field is stronger or weaker than average. These are the types of anomalies that scientists have traditionally studied, as they provide valuable insight into the types of rocks and minerals beneath the Earth's surface. However, the magnetic anomalies associated with the deep-seated structure being studied here are unlike anything previously encountered. The fluctuations detected seem to be more complex than a simple distortion of the magnetic field. Rather than a smooth variation, these anomalies appear to pulse in a rhythmic, repeating pattern, suggesting that something dynamic is at play within the Earth's depths. What's more, the frequency of these pulses doesn't align with any known natural processes. In typical cases of magnetic anomalies, the fluctuations are irregular and often tied to geological features like mineral deposits or volcanic activity. In this case, the consistency and timing of the pulses suggest the presence of something much more organized and potentially more powerful beneath the Earth's surface. Some scientists are beginning to speculate that these pulses could be related to some form of energy or power deep within the Earth, something that we don't yet fully understand. Could these magnetic pulses be the result of an underground system of currents or an electrical phenomenon? If so, how could such a system exist without disturbing the surface or being detected until now? The idea of an electromagnetic system deep within the Earth challenges the current understanding of geophysics and poses several intriguing questions. One possible explanation is that these anomalies are a byproduct of a large-scale, underground geoelectric system. If this system operates like a battery, storing and releasing energy in a rhythmic pattern, it could explain the consistency of the pulses. Such a process would be unlike anything we've seen before, but it could have been a natural part of Earth's internal dynamics for millions of years, simply going unnoticed due to its subtlety and the lack of advanced monitoring technology. Some researchers also point to the possibility that these magnetic pulses could be tied to an underground cavern system or a network of tunnels within the Earth's crust. If such a system exists, it could potentially amplify or modulate the Earth's magnetic field in ways we've never observed. This idea is still speculative, but the nature of the pulses is leading many to consider it more seriously. Another avenue of investigation involves the role of water and fluids in the creation of these magnetic anomalies. As strange as it may sound, water plays a crucial role in the conductivity of the Earth's crust. Seismic studies have revealed the presence of vast amounts of water deep within the Earth, and it's possible that this water could be contributing to the magnetic pulses. If water is interacting with certain mineral deposits in the Earth's crust, it could create electrical currents that generate the rhythmic magnetic anomalies observed. To explore this further, scientists are looking into the composition of the rocks surrounding the anomaly. They are studying the chemical signatures of the minerals and how they might interact with water, heat, and pressure to create these magnetic fluctuations. The presence of certain metals, such as nickel, iron, or cobalt, could play a key role in amplifying the effects, and further analysis may uncover a direct link between these materials and the magnetic anomalies. There's also the possibility that the magnetic anomalies are related to a larger, more profound phenomenon, one that could fundamentally alter our understanding of the Earth's inner workings. Some researchers have suggested that the anomalies may be the result of a new type of geophysical activity, one that has never been observed before. Could it be that this structure represents a source of power, an energy source so potent that it affects not just the magnetic field, but the very dynamics of Earth itself? To investigate this possibility, researchers are pushing for deeper exploration of the anomaly's location. Ground-penetrating radar, magnetometers, and other specialized instruments are being deployed in the hope of detecting further clues about the nature of the magnetic disturbances. These devices can map the magnetic field in greater detail, revealing areas where the magnetic anomalies are strongest and possibly even uncovering patterns that could reveal the true source of the pulses. One of the most interesting aspects of these magnetic anomalies is their potential connection to a wider phenomenon beyond the Earth itself. Some theorists believe that such anomalies could be linked to cosmic forces, a distant solar flare or interstellar event that interacts with the Earth's magnetic field in unusual ways. Although this theory remains speculative, the rhythmic nature of the anomalies does suggest that there could be an external influence, something beyond the planet's immediate environment. If these anomalies are indeed related to cosmic forces, it would add an entirely new layer of complexity to the situation. Perhaps the Earth's magnetic field is interacting with forces on a galactic scale, ones that we've only just begun to detect. This would not only deepen our understanding of Earth's role in the larger cosmos but could also offer clues about how the planet interacts with distant phenomena that affect life in ways we can't yet fully comprehend. As the research progresses, more and more instruments are being brought to bear on this mystery. The magnetic anomalies continue to puzzle scientists, and with each new layer of data, questions arise that challenge our understanding of the planet itself. The more we learn about these phenomena, the more we realize how much we still don't know. One of the key developments in this investigation is the role that seismic activity may be playing in these magnetic fluctuations. Typically, seismic waves, those vibrations generated by earthquakes or underground movements, travel through the Earth's crust, providing us with valuable data about the interior structure of the planet. What's striking about the magnetic anomalies we're observing, however, is that they appear to be occurring in conjunction with seismic events, sometimes even in places where no surface-level tremors have been recorded. This correlation between magnetic anomalies and seismic activity suggests a potential link between the Earth's magnetic field and tectonic movements. The connection between the planet's shifting plates and its electromagnetic properties has been an area of growing interest for geophysicists, and these anomalies may be providing us with the first real-time evidence of how seismic events affect the magnetic field on a much deeper level. In particular, researchers are focusing on how pressure and heat within the Earth's mantle might interact with the magnetic minerals in the crust, potentially generating the kinds of irregularities we're seeing. As tectonic plates shift, the ground above them experiences tremendous stress, and this could lead to changes in the alignment or structure of the magnetic minerals in the area. It's also possible that certain elements buried deep within the Earth, when exposed to these stresses, could create a localized change in the magnetic field, contributing to the anomalies. Seismic activity may also be playing a role in the amplification of these pulses. Some researchers believe that when certain tectonic plates shift, they could trigger a chain reaction of events deep within the Earth's structure. This chain reaction could influence the behavior of subterranean systems, creating pressure zones or conductive pathways that enhance or amplify the magnetic anomalies. At the heart of these investigations is the question of whether these anomalies are natural, part of the ongoing processes of Earth's geology, or if they indicate something entirely new, a system that has been hidden beneath the Earth's surface, only now becoming detectable with advancements in technology. What's more, these anomalies are not just an isolated curiosity. As more data is collected, scientists are beginning to notice patterns in the locations of these fluctuations. Certain regions of the Earth seem to be more prone to these magnetic pulses than others. These hotspots, scattered across the globe, appear to share common geological traits, such as high levels of volcanic activity or significant fault lines. These locations may be directly tied to the planet's tectonic processes, but the exact cause of the magnetic disturbances in these areas remains unclear. Interestingly, some of the regions experiencing these anomalies are also known for their deep, unexplored caverns or underground voids. Could it be that these magnetic pulses are being generated by something beneath the surface that we're only beginning to discover? The idea that there may be vast underground chambers, tunnels, or even completely undiscovered structures within the Earth that could be influencing the planet's magnetic field is both tantalizing and unsettling. This leads to a more speculative line of inquiry. Could these anomalies be caused by an undiscovered form of energy or power deep within the Earth? It's possible that this phenomenon is tied to some kind of electromagnetic system that has developed over millions of years, perhaps a natural or unknown force interacting with the Earth's magnetic field in ways we don't fully understand. This could be part of a natural process, but if it's linked to an unknown energy source, it opens up an entirely new field of study. Another fascinating possibility is the idea that these anomalies could be connected to volcanic activity. Volcanoes and their related processes are known to generate significant magnetic fields due to the movement of magma and minerals within the Earth's crust. Some scientists speculate that these anomalies could be tied to a previously undetected subterranean volcanic system that has the ability to create large-scale electromagnetic disturbances. Given that many of the magnetic anomalies are occurring near known volcanic regions, it's possible that the pressure and heat within the Earth's mantle could be contributing to a massive release of energy, energy that manifests as magnetic pulses. If this theory holds, it could mean that we are on the brink of discovering new connections between the Earth's volcanic activity and its electromagnetic behavior. There's also the idea that the magnetic pulses are somehow linked to the movement of fluids beneath the surface. Geologists have long known that water plays a vital role in the planet's tectonic processes, particularly in areas where there are large, deep aquifers or subterranean rivers. If these underground water systems are interacting with the minerals and metals in the Earth's crust, they could be creating an electric current, which in turn could generate the magnetic fluctuations being observed. What makes this theory particularly intriguing is the potential for these underground fluids to form part of a larger system that is regulating the planet's electromagnetic properties. If these fluids are circulating within the crust, they could be acting as a conduit for electrical energy, amplifying the magnetic pulses and creating the patterns that researchers are now tracking. The more scientists investigate, the clearer it becomes that there are far more factors at play beneath the surface than we've previously realized. As we delve deeper into the ongoing investigation of the magnetic anomalies, one aspect that continues to intrigue scientists is the potential for these disturbances to be linked to previously undiscovered geological features. The Earth's interior is far more complex and dynamic than we ever imagined, and these magnetic fluctuations may represent the outward manifestation of deeper processes that are beyond our current understanding. In some ways, these anomalies might be the Earth's way of signaling that there are things we still don't know, hidden under layers of rock, metal, and time. Recent studies have started to focus more on the Earth's core, which plays an integral role in generating the planet's magnetic field. The core is composed of two layers, a solid inner core and a liquid outer core made up primarily of iron and nickel. The movement and convection within the liquid outer core are responsible for generating the Earth's magnetic field through a process known as the geodynamo. What makes these magnetic anomalies so perplexing is that many of the fluctuations appear to be linked to surface-level phenomena, not deep within the core, where the geodynamo operates. This suggests that the anomalies may not be generated solely by the typical mechanisms of the Earth's magnetic field but rather by other forces, possibly in the mantle or crust, or even something completely different. One intriguing theory being explored is the potential impact of gravitational forces on Earth's magnetic behavior. Tidal forces caused by the Moon and the Sun, which have long been known to affect the planet's oceans, might also influence the Earth's interior in ways that were previously underestimated. Some scientists are now investigating whether these gravitational forces are strong enough to cause subtle changes in the Earth's magnetic field, particularly in areas where the crust is thin or in regions of intense seismic activity. This line of thought suggests that the magnetic anomalies could be a direct consequence of the Earth's response to celestial bodies, adding another layer of complexity to the puzzle. Equally fascinating is the growing evidence that these magnetic fluctuations might be tied to underground electromagnetic fields created by natural and anthropogenic processes. For example, large-scale mining operations, deep-sea exploration, and geothermal energy production all involve the extraction of minerals or the manipulation of subterranean systems, and some of these activities are capable of generating localized magnetic fields that could contribute to the anomalies. While much of this is still speculative, it raises the possibility that human activities could be playing a role in influencing the planet's magnetic field in ways we haven't fully grasped. In remote regions where human activity is minimal, the anomalies still persist, suggesting that natural phenomena may be the primary cause. There are some who believe that these magnetic disturbances could be linked to the existence of so-called earthquakes of the mind, tremors or disturbances that are not caused by conventional seismic activity but instead by unknown processes deep within the Earth. These could potentially be the result of previously unknown physical phenomena or even electromagnetic interactions within the Earth's mantle, processes that remain undetectable with our current technology. Researchers are also beginning to explore the possibility that the Earth's magnetic field might not be as constant as previously assumed. The magnetic poles, for example, are known to shift over time in a process called geomagnetic secular variation. These shifts have occurred throughout Earth's history, and some scientists believe that the magnetic anomalies we are detecting could be linked to such shifts. The Earth's magnetic field might be experiencing subtle but significant changes that we're only beginning to detect, leading to the appearance of localized anomalies. Moreover, there's growing speculation that these anomalies may be tied to future shifts in the Earth's magnetic poles. The last time such an event occurred was hundreds of thousands of years ago, but with current technology, scientists can track the movement of the poles in real time. While these shifts typically happen slowly, they can have significant effects on the planet's magnetic field. If the anomalies we're seeing are related to these shifts, it could mean that we're on the brink of experiencing another magnetic pole reversal, one that may have profound consequences for both the planet and our technology-driven society. This theory has sparked a great deal of interest within the scientific community, especially since a pole reversal is considered a natural event in the Earth's geologic timeline. While the last magnetic pole reversal occurred during the Pleistocene epoch, evidence suggests that the Earth's magnetic field may be undergoing significant changes right now, and some researchers are beginning to connect these changes to the anomalies we are observing. The idea that the magnetic poles could be on the move again has prompted scientists to reconsider the long-term stability of the planet's magnetic shield. As this research continues to unfold, one thing becomes abundantly clear: the implications of these magnetic anomalies are far-reaching, not just for Earth science but for technology, climate science, and even our understanding of space weather. The Earth's magnetic field plays a crucial role in protecting us from harmful solar radiation, so any fluctuation or weakening of this field could have significant consequences. If these anomalies are precursors to a shift in the magnetic poles or other fundamental changes within the Earth's core, the potential impacts on our technological infrastructure, satellites, communication systems, and even power grids could be dramatic. What's more, the presence of magnetic anomalies could influence the way we understand space weather, which is heavily influenced by the interaction between the Earth's magnetic field and solar winds. The discovery of these anomalies may provide us with valuable insights into how space weather affects Earth on a deeper level, allowing scientists to better predict and prepare for potential disruptions in global communications or power systems. The relationship between solar activity and the Earth's magnetic field is already a hot topic, and these magnetic anomalies may be the key to unlocking a whole new chapter in that research. The discovery of these anomalies could also provide clues about Earth's role in the broader cosmos. Earth is not an isolated system but is influenced by countless forces, both within the planet and from outer space. Understanding these magnetic fluctuations may allow scientists to refine models of the Earth's interaction with cosmic events like solar flares, gamma-ray bursts, and other high-energy phenomena. As we uncover more about these anomalies, we may uncover a deeper, more intricate relationship between our planet and the forces that govern the universe. Now that we've explored the magnetic anomalies and their possible implications, let's shift focus to another fascinating aspect of Earth's changing dynamics: the unusual seismic activity that has been detected in various parts of the world. Over the past few decades, scientists have observed a marked increase in tremors, which are shaking the foundations of our understanding about the Earth's stability. This trend has prompted many to ask, is the Earth truly undergoing a significant shift, or is there something deeper occurring beneath the surface that we are yet to fully comprehend? Seismic anomalies are not new to science. Earthquakes, for instance, have been occurring for millions of years due to the tectonic movements of the Earth's lithosphere. However, what has become increasingly alarming are the patterns in seismic events, specifically the frequency and intensity of tremors that don't correspond with traditional seismic activity in fault zones. Some areas, which have never been prone to major earthquakes, are now experiencing smaller, more frequent tremors. The sudden increase in seismic activity in places like the eastern United States, areas of the Mid-Atlantic Ridge, and even regions within the oceanic crust, are causing many to wonder whether the Earth's internal systems are beginning to show signs of instability. What's even more perplexing is the recent increase in deep-focus earthquakes. These earthquakes originate much deeper in the Earth's mantle than typical shallow-focus ones, which occur closer to the surface. They are less common but have been observed more frequently in recent years. While the cause of deep-focus earthquakes is still under investigation, some researchers believe that they may be related to the movement of magma beneath the Earth's crust or perhaps even the destabilization of the mantle itself. These deeper quakes are different in character compared to their shallow counterparts, and could indicate that the Earth's tectonic processes are undergoing changes that we haven't yet fully understood. In addition to these unusual seismic patterns, there has been an uptick in the discovery of unusual tectonic formations beneath the Earth's surface. In recent years, geologists have been uncovering massive undersea ridges and deep trenches that could be indicative of tectonic movements that have long remained hidden. These deep-sea anomalies could be leading to new fault lines, which, if triggered, may cause seismic shifts on a scale previously unseen in certain regions of the globe. Another troubling aspect of these seismic disturbances is their connection to volcanic activity. Many of the regions experiencing abnormal tremors are also home to active or dormant volcanoes. The correlation between these two phenomena is far from coincidental. Earth's seismic activity is intricately tied to the movement of molten rock, or magma, beneath the surface, which can build up pressure over time and lead to volcanic eruptions. As we witness more frequent tremors in regions with volcanic activity, it's possible that the increased seismic activity is a precursor to major eruptions in some areas. The Ring of Fire, an area notorious for its intense volcanic and seismic activity, continues to be one of the most closely monitored regions on Earth. From Indonesia to the west coast of North America, this region experiences frequent earthquakes and volcanic eruptions, but in recent years, certain areas within the Ring of Fire have been seeing intensified seismic activity. Scientists are concerned that these heightened tremors could signal larger, more destructive events on the horizon. In some cases, seismic activity in these regions has been increasing, leading to speculations that these tremors might be linked to upcoming volcanic eruptions, as pressure continues to build beneath the Earth's crust. Moreover, these seismic anomalies could be linked to broader planetary changes. Scientists have started to investigate the connection between the Earth's shifting magnetic field, seismic disturbances, and volcanic activity. The idea that these phenomena may be interconnected has been gaining traction in recent years. Could the unusual shifts in the Earth's magnetic field be causing changes in the behavior of tectonic plates? Could the magnetic anomalies be exerting pressure on certain fault lines, making them more susceptible to seismic activity? While this remains a speculative area of research, the potential relationship between these two phenomena could open up new avenues for understanding the Earth's internal dynamics. But seismic anomalies aren't limited to Earth's surface. The depths of our planet's oceans have also been revealing strange patterns that could be indicative of seismic changes below. Seafloor topography is an area that remains poorly understood due to the vastness of the oceans and the difficulty of studying these remote regions. Yet, recent studies have uncovered previously unknown underwater volcanoes and shifting tectonic plates along the ocean floor. As these seafloor movements are often unnoticed by the general public, they could lead to more powerful undersea earthquakes and tsunamis, with consequences for coastal regions and marine life alike. One of the most remarkable discoveries in recent years is the detection of unusual seismic waves traveling faster than expected. These waves, known as fast-traveling seismic waves, suggest that there could be significant changes occurring within the Earth's lower mantle. They appear to travel at speeds that surpass the normal velocity of seismic waves, which could mean that the material within this part of the Earth is undergoing rapid changes. Some scientists believe that these anomalies could be indicative of a massive shift in the Earth's tectonic systems, potentially setting the stage for seismic events of greater magnitude in the future. As this seismic mystery unfolds, it's essential to examine the potential implications of these changes for global infrastructure. Increasingly, geologists are pointing to the fact that many of the world's most heavily populated areas are located near active fault lines or volcanic regions. Cities such as San Francisco, Tokyo, Mexico City, and even Istanbul sit in precarious positions on the Earth's tectonic map, and the rising frequency of earthquakes could signal an increased risk for catastrophic events. If seismic disturbances continue to grow in intensity and unpredictability, the world may need to reevaluate its approach to disaster preparedness and building resilience in regions prone to seismic activity. Equally concerning are the long-term effects of this heightened seismic activity on global ecosystems. Earthquakes and volcanic eruptions can have far-reaching impacts on wildlife habitats, biodiversity, and even the atmosphere. Large-scale volcanic eruptions can spew ash and sulfur dioxide into the atmosphere, leading to temporary climate cooling and disrupting weather patterns across the globe. As seismic activity continues to increase, the resulting natural disasters could exacerbate the effects of climate change, affecting everything from crop production to human migration patterns. In addition, these seismic anomalies could influence other areas of scientific exploration, such as our understanding of natural resources and energy production. Oil and gas reserves, mineral deposits, and geothermal energy sources are all intricately tied to the Earth's tectonic movements. The discovery of new seismic disturbances might also mean the discovery of untapped resources, potentially both a boon and a challenge. While new energy sources could be found in previously unreachable locations, the increased seismic activity might also pose risks to ongoing extraction operations, particularly in volatile regions. As we continue to explore these seismic anomalies, it becomes clear that they could be just one part of a much larger, interconnected system of changes happening beneath the surface. Earth, as a dynamic planet, is constantly undergoing shifts in its core, mantle, and crust, yet there are signs that these changes are happening more rapidly and unpredictably than ever before. We are beginning to observe more frequent and intense shifts in tectonic plates, which, in turn, have broader implications for our planet's overall behavior. These seismic events, as unsettling as they may seem, might not be isolated incidents. Instead, they could signal a deeper, underlying transformation in the Earth's geological processes. In addition to the seismic disturbances, another emerging phenomenon that warrants attention is the shifting behavior of volcanic activity. As we've seen in regions such as the Pacific Ring of Fire, volcanoes that were once dormant are now waking up, spewing ash and lava, and leaving entire communities in their wake. Some researchers believe that this uptick in volcanic eruptions may be directly connected to the seismic activity we've been witnessing. As the plates shift and interact with each other, they could be triggering volcanic eruptions that have been dormant for centuries. But it isn't just the physical eruptions themselves that pose a danger. The impact of volcanic activity on the global climate is another crucial aspect to consider. Volcanic eruptions release significant amounts of gases like sulfur dioxide into the atmosphere, which can cool the Earth temporarily by reflecting sunlight away from the planet's surface. This phenomenon, called volcanic winter, has the potential to disrupt weather patterns and cause crop failures, leading to widespread food insecurity. When combined with other stressors like climate change and environmental degradation, the consequences could be dire. It's also worth noting that these phenomena are not limited to the surface of the Earth. As our technology improves, scientists are gaining a clearer picture of what's happening beneath the Earth's surface in ways they couldn't before. New seismic imaging techniques are allowing us to map the Earth's interior in unprecedented detail, revealing complex networks of fault lines and magma chambers that were once hidden from view. These revelations could help explain why certain regions are more susceptible to earthquakes, volcanic eruptions, and other natural disasters, and they may also give us a glimpse into the processes that drive these events. One area of focus for researchers has been the study of hotspots, areas where volcanic activity is not necessarily tied to tectonic plate boundaries but instead arises from deep within the Earth's mantle. These hotspots, such as the one beneath the Hawaiian Islands, are thought to be fed by plumes of molten rock rising from the Earth's core. The intense heat from these plumes can melt the crust above, forming volcanoes over time. Scientists are investigating whether there are other hotspots around the world that have yet to be fully discovered, which could help explain some of the more unusual patterns of volcanic and seismic activity we've been observing. These discoveries are opening up new avenues of inquiry, especially when it comes to predicting future natural disasters. While it's difficult to forecast exactly when and where these events will occur, scientists are working on ways to predict seismic and volcanic activity more accurately. The hope is that by improving our understanding of the Earth's inner workings, we can develop better early warning systems that might save lives and protect communities from the worst effects of these disasters. Some countries, particularly those located in regions with high seismic or volcanic risk, have already begun implementing advanced monitoring systems, including satellite technology and ground-based sensors, to track changes in the Earth's crust and mantle. These technologies have the potential to provide valuable lead time, allowing for evacuations and other protective measures before disaster strikes. Yet, as we gain more knowledge about these geological processes, we are faced with the difficult reality that some of these events may be beyond our control. The forces driving earthquakes, volcanic eruptions, and other natural disasters are deeply embedded within the Earth itself, far beyond our ability to influence or alter. And while human ingenuity and technological advances have allowed us to mitigate some of the impacts of these events, we cannot predict every tremor or eruption. We must prepare for the possibility that, despite our best efforts, these powerful natural forces will continue to shape the planet in ways that are unpredictable. As we explore these changes, we also need to reflect on the broader implications for our global society. The impact of these seismic events extends far beyond the immediate damage to infrastructure and communities. As natural disasters become more frequent and intense, there are likely to be ripple effects across various sectors: agriculture, energy, transportation, and even global economies. Communities that are already vulnerable to the impacts of climate change or poverty may be disproportionately affected by these seismic disturbances, exacerbating existing inequalities. This is why it's so crucial to continue investing in disaster resilience and adaptation strategies. While we may not be able to stop the Earth from shifting beneath us, we can take steps to mitigate the effects of these shifts on our lives. This means improving our infrastructure to withstand earthquakes, enhancing building codes to protect against the devastating effects of volcanic eruptions, and strengthening early warning systems to ensure that people have time to react before disaster strikes. It also means being proactive in addressing the root causes of vulnerability, such as poverty, lack of education, and inadequate healthcare, so that communities are better equipped to recover when these events occur. Furthermore, the increased understanding of seismic anomalies opens the door to a more global collaboration in tackling these challenges. As the frequency of seismic events rises and as the effects of these events become more apparent, it is essential that countries around the world work together to share information, resources, and expertise. After all, the Earth's geology is not bound by national borders. A seismic event in one country can have far-reaching effects that impact neighboring countries and, in some cases, the entire planet. By sharing data, research, and best practices, nations can develop more effective solutions to mitigate the risks posed by these events and enhance our collective ability to respond. In many cases, the geological changes we're witnessing could be indicative of a deeper reset of Earth's systems. One of the more intriguing phenomena that scientists are beginning to focus on is the possibility that these shifts may signal an eventual change in the Earth's magnetic field. While this may sound like something out of a science fiction novel, there is real scientific evidence pointing to a phenomenon known as geomagnetic reversal, a process where the planet's magnetic poles flip. It's a rare event, with the last major reversal occurring over 700,000 years ago, but scientists have found clues suggesting that Earth's magnetic field may be undergoing changes right now, with the poles potentially heading toward a reversal. If this happens, the effects could be far-reaching. The magnetic field acts as a protective shield, blocking harmful solar radiation and cosmic rays from reaching the Earth's surface. A shift or weakening of this field could expose the planet to higher levels of radiation, which could affect everything from satellite communication systems to power grids. Some experts even believe that geomagnetic reversals could trigger increased seismic activity, as changes in the magnetic forces may impact the movements of molten rock beneath the Earth's surface. Though it's difficult to predict the exact timing of such an event, scientists are monitoring the Earth's magnetic field with increasing precision, using data from satellites and ground-based sensors to track its movements. The connection between seismic and volcanic activity and a potential geomagnetic reversal is still a subject of active research. However, it's undeniable that these events are all intertwined in ways we are just beginning to understand. As our knowledge of these geological processes deepens, we may uncover even more surprising connections that will further change our view of the planet's dynamics. Yet, even without a full understanding of these processes, there are still practical steps that we can take to better prepare for the inevitable changes that will occur. Governments, scientists, and communities around the world must continue to invest in research and technology that can provide early warning systems for seismic and volcanic events. As we've seen in recent years, advancements in seismology and volcanology have allowed for better detection and forecasting, enabling more effective evacuations and disaster management. This progress is critical, especially as the global population continues to grow and as urban centers expand into areas that are more susceptible to seismic and volcanic risks. In addition to the technological aspect, there is also a growing need for community education and preparedness. While early warning systems can certainly help mitigate the damage of seismic and volcanic events, individuals must also be equipped with the knowledge and resources to respond appropriately in the event of a disaster. From learning basic earthquake safety protocols to understanding evacuation routes, there are countless steps that people can take to increase their resilience in the face of disaster. This type of community preparedness, coupled with effective government response, can significantly reduce the human toll that these events take. But the role of individuals doesn't stop at preparedness. As we move forward, it's essential that we continue to build a culture of environmental stewardship that acknowledges the dynamic nature of Earth's systems. We must not only focus on surviving these changes but also on living in harmony with the natural world around us. That means addressing the root causes of environmental degradation, such as deforestation, pollution, and the overconsumption of natural resources. By protecting the Earth's ecosystems, we can help preserve the delicate balance that keeps our planet habitable, even as its internal systems continue to shift and change. Ultimately, the key to navigating these seismic anomalies and the broader changes occurring on Earth lies in our ability to adapt and innovate. As humanity faces these challenges, we have the opportunity to harness our collective knowledge, creativity, and resilience to not only survive the inevitable changes but thrive in the face of them. The more we learn about our planet's inner workings, the better equipped we will be to anticipate and mitigate the effects of these natural phenomena. And, as we continue to deepen our understanding of Earth's geological processes, we may discover new ways to work in partnership with the planet, finding solutions that benefit both humanity and the natural world. In the coming years, we are likely to witness more seismic and volcanic events, each one adding another layer to our growing understanding of the planet's dynamic behavior. But with each discovery, there is also the potential for greater resilience, for the development of new technologies, and for a deeper connection with the world around us. As we move forward into this new era of exploration, we must approach the mysteries of the Earth with both humility and hope, knowing that through our knowledge and innovation, we can continue to adapt to and thrive in an ever-changing world. As we step back and reflect on the incredible journey we've taken through Earth's seismic and volcanic phenomena, as well as the complex forces that govern our planet's behavior, one thing becomes abundantly clear: Earth is a dynamic and ever-changing system. From the shifting tectonic plates beneath our feet to the volcanic eruptions that reshape landscapes and the potential for geomagnetic reversals that could alter our very way of life, the forces at play are both awe-inspiring and humbling. These phenomena remind us of the vastness of the Earth and the forces of nature that operate far beyond our comprehension. At the same time, they also serve as a call to action, a reminder that our survival and well-being are intricately tied to the health of the planet and the systems that sustain us. As we witness the increasing frequency of seismic and volcanic events, we must not only focus on preparing for the challenges they bring but also seek to better understand the processes that drive them. Our ability to adapt to and mitigate the effects of these events will be critical in the coming years. And the more we know about the inner workings of Earth's geology, the more prepared we will be for whatever the future holds. The Earth's magnetic field, often an invisible force in our daily lives, is a prime example of how interconnected our world truly is. Its potential weakening or reversal could have far-reaching consequences, but it also underscores the incredible complexity of the planet's systems. If we take the time to study these processes, to embrace the power of science and innovation, we may discover new ways to protect ourselves and the environment, ensuring that future generations inherit a planet that is not only capable of supporting life but also resilient in the face of change. At the same time, the connection between human activity and the Earth's changing systems cannot be ignored. Environmental degradation, overconsumption of resources, and the loss of biodiversity are all factors that can exacerbate the challenges we face. By recognizing the delicate balance that sustains life on Earth, we can begin to make more conscious decisions about how we interact with the environment. Whether it's reducing our carbon footprint, investing in sustainable energy sources, or supporting conservation efforts, each small action we take can contribute to a larger movement toward harmony with the planet. It is also crucial that we continue to invest in technologies that allow us to detect and predict natural disasters more accurately. Advances in seismology, volcanology, and space-based geophysical measurements are already giving us better tools to understand and anticipate these events. Early warning systems, satellite monitoring, and data analytics are transforming the way we respond to natural disasters, giving us the potential to save lives, reduce economic losses, and protect vulnerable communities. Equally important is the role of education and community preparedness. When individuals understand the risks they face and are equipped with the knowledge to act, they become better prepared to protect themselves and their families during an emergency. From basic earthquake safety practices to understanding evacuation routes during volcanic eruptions, we must continue to empower people with the tools they need to stay safe in an unpredictable world. In times of disaster, the strength of a community lies in its preparedness, its ability to act swiftly and effectively, and its unwavering support for those in need. As we move forward, we must also embrace the opportunity to explore new frontiers of understanding. The mysteries of Earth's inner workings are still unfolding, and with each new discovery comes a deeper connection to the planet we call home. The more we learn about the forces that shape our world, the more we can appreciate the delicate balance that sustains life on Earth. In the end, it is not just about surviving the changes that come our way but learning to thrive in harmony with the planet's ever-evolving systems. The future is undoubtedly filled with uncertainties, but it is also rich with potential. By continuing to study, innovate, and educate, we can rise to the challenges of an ever-changing world and work together to ensure a more resilient and sustainable future. As we face the seismic shifts and volcanic eruptions of tomorrow, let us remember that we are not powerless. With knowledge, preparedness, and a deep respect for the natural world, we can navigate the challenges ahead and build a future where both humanity and the Earth can thrive in harmony. In this journey, we find not only a call to action but an invitation to connect more deeply with the planet, understanding its rhythms and cycles, and ultimately embracing our place within the larger tapestry of life on Earth. If you've found this exploration into Earth's hidden forces and mysteries as fascinating as we have, don't forget to subscribe and like this video. By doing so, you'll stay updated on all our future content, diving even deeper into the wonders and secrets of the planet we call home. Stay curious, stay safe, and thanks for joining us on this incredible journey.